Hey everyone, so in this video we are picking up right where we left off. In the last video we made a simple day-night cycle, and really all we did is we took a directional light, added a rigid body component, and then used a single line of script to add angular velocity so as that this continues to spin along the x-axis. That way the direction of the light keeps changing and rotating. A full revolution, a full 360 degrees, would be a full day-night cycle. So the key is knowing how to turn this into a predictable number, because the number 1 really doesn't mean anything. Yes, it has a calculation, but you really want to convert this into something that is predictable based on seconds. Why? Because if you could break this down to change per second, you can then use IEnumerator, which uses a delay also measured in seconds, and then you can synchronize all kind of things. So you can synchronize the change of the color of the sky with the moving of the direction of the light. So it's imperative for us to turn this into an amount per second. I'm just going to paste in the equation. You really don't actually need to understand the equation. It's very short. You only really have to understand one number within that equation. Okay, so let's do that. So let's paste. So in short, Unity is moving the camera a certain amount of radians. I'm not going to explain what a radian is. All you need to know is that what you're doing is you're converting radians to degrees. Why? Because like we said, we want it to be 360 degrees, a full rotation. And that's what this does. 2 times pi. MathF is how you reference certain predetermined mathematical functions. Pi has a pre-existing value, okay? So 2 times pi divided by 60. As I was saying, this is really the only number you have to understand. This is dividing it by 60. Why? Because this converts it to seconds. You've taken the entire radius, not the radius, I guess the circumference. You take the entire circumference and you're dividing the movement up into 60 units. And by doing that, you can now have 1 unit per second. Okay? So that's all that does. So like I said, please don't let the math bother you. It's just this is the x value now. Okay, so it's just a parenthesis, 2 times mathf dot pi, close parentheses, divided by 60. So since this is 60 seconds, one entire rotation will be 1 minute because it's 60 seconds per minute. So if you want this to be 5 minutes, you just change this to 300. If you want this to be 10 minutes, you change this to 600. So that's what we're saying about that's really the only part you have to understand is you're changing the increment. You're changing how long it takes for this to happen. How long do you want an entire cycle to take? And so it's just multiplying it by 60. So, and again, 60 for 60 seconds. So we'll leave this to 1 minute. And now that we've done that, I would run it and that way you could see it, but why have you sit here and watch it for 1 minute? By doing that, we now are having the directional right rotate so as that in 1 minute, 60 seconds, it rotates the entire 360 degrees, has done a full rotation, and therefore 1 day-night cycle. So that's how you take those kind of random numbers we were using, and now we make something that is predictable and measurable and consistent with the clock. So what do we do next? Next, what we want to do, we said we want to now change the color of the sky. So rather than using the pre-made skybox and have its pre-made calculations, you're going to manually control the color. Maybe you want this to be more stylized. Maybe you want it to be a little bit more cartoonish. Maybe you don't want to have that generic Unity look to it. So we're going to click on the main camera, and rather than using skybox, we're going to use solid color. So this field that's been here that we weren't using, you can directly change this through code, through a script, to have it change. And like we said, we already know that 1 day-night cycle will be 60 seconds. Therefore, what we want is the sky to go from pitch black to peak brightness within 15 seconds, and then in the next 15 seconds, go from peak brightness back to pitch black. Why? Because that's the day part of the cycle. And then for 30 seconds, there'll be no change. And then it repeats because that's the full 60 seconds. I'm just going to start pasting in code because it's hard to wrap your brain around until you actually see the code. So let's right click, create C#, and we will call this sky change. We take our camera. We don't need to add any additional components other than the sky change script, and we open that up. First thing we need are a couple variables. So let's just paste these right in. And you can just pause the video. I've received feedback that people didn't like me typing out during the video. It drags out the video, so we'll just paste it in and you can just pause the video. So the first thing we're doing is we're creating a color variable. So again, we're saying that it's private, so it's not going to be in the inspector. What kind of variable it is? It's color. And then what's the name of the variable? We're going to use sky RGB. Why? Because that's what we're changing. We're changing RGB. And as always, the name of the variable doesn't really mean anything to Unity, but it means something to you. That's what you're doing with this. And we're setting it to a new color of 0, 0, 0, because we're going to have it start at black. So this is red, this is green, this is blue. It ranges from 0 to 1. So 0, 0, 0, pitch black. Okay. This is going to be used to measure how many seconds have passed. We'll get to that in a minute, but that's, again, just it's private because it doesn't need to be in the inspector. What type of variable is an integer? And what's the name of the variable? We'll just use I. You can call it whatever you want. That's just back in the old days of BASIC, I was often used for a variable for how many times something is used in like a for loop, that kind of thing. But you can use whatever letter or letters you want, and I'll just set that to 1 because we're going to do, again, 15. So we're going to start at 1 and go to 15. Okay, so next. So when the camera instantiates, when the scene is created, we want this to be the starting color. So what we're going to do, let's paste this in here. Again, just pause the video. Get component camera. So the script is attached to the camera. Camera component right here. Background color, background color. The verbiage is a little bit different. It's just because it's Unity. And it's equal to what? It's equal to that variable we just created. See how it helpfully selects it for you so you know where else you're using it? So this value will be applied here. And so therefore the start color won't be this. It's going to be pitch black. And then start coroutine, we have not written out the coroutine yet. And so that's why it doesn't like it. This will be the name of the coroutine. Now, before I start pasting in the coroutines, what you're going to see, you're going to see 3 coroutines. I'll do one at a time. They're going to look very, very similar. And the only reason why I did it this way is so it doesn't have to be more complex coding. There's always a trade-off. And just like I said in the last video, I'm not saying this is the only way. I'm not saying this is the best way. I think this is just the clearest and simplest way to explain it. Again, you can always optimize this on your own. So let's go ahead and grab that code and paste that in. Okay, so outside of start, outside of update, we're going to paste this in, and we are just going to go through this one line at a time. So IEnumerator AM cycle. So that's what we're just looking at, okay? Because the reason why we're breaking this up into an AM and PM, because we want we want the green and blue to get brighter for half of the day cycle, because that's the AM part, but then we want it to get darker for the PM cycle. That's why we're going to break it up into 2 15-second cycles rather than 1 30-second cycle. Technically, it's probably not getting darker, into like mid-afternoon, but then that gets really complicated, and I think that this is just a good intermediate step. Okay, so just like any other IEnumerator, it starts off yield return new, wait for a certain amount of seconds measured in seconds, or should I say wait for a certain amount of time measured in seconds. So yield return new, wait for seconds, 1 second. So this isn't going to look great because you're going to very clearly see the color change every single second. This is just for demonstrative purposes. You would actually use a much smaller number as long as it is evenly divisible into 15. So maybe it would be half a second, maybe it would be a quarter of a second. Your choice. Again, this is just for demonstrative purposes to show you that it can be synchronized with the rotation, the changing of the daylight. So this is the main loop within this routine. It's saying if I, so that's the variable we created a few seconds ago, if it's less than 15, again, we're trying to measure how many seconds have passed, okay? So if I is still less than 15, increment I by 1, skyrgb.g. So this is a variable. We said it's a color. So it has 3 colors, R, G, and B. By doing that dot, we're drilling down into the G in the RGB. Okay. No, you don't have to put the letters RGB like I did. Again, that's just to let you know what you're doing with this. As long as you declare it as a color, you can do this. So skyrgb.g, so we're changing the G value. We're going to add to its current value, so plus equals 0.05f. Again, you have to use an f if you're using decimals. So skyrgb.g, the green is going to be incremented by 0.05. Again, it ranges from a total of 0 for no green to 1 for maximum green. Likewise, we want the blue to increase. We want this to get brighter. So skyrgb.b plus equals 0.07. So I'm hoping that you see the similarity there, that it's really kind of rinse and repeat, that you're incrementing a certain color within that variable. You then want to apply that variable right here. Get component camera.background color skyrgb, just like we did here. Rinse and repeat. Okay, so we checked to make sure it was under 15. We incremented. We changed RGB. We applied it. You don't have to do the debug. I was just there to make sure it was working. And then we're going to continue with the AM cycle. But this is all within an if. So eventually, this won't be true. If it's not true, then do else. Else, we need to set I back to 0. Because we want to do another routine, another count, but within the next coroutine, and start the next coroutine. And it's underlined because we haven't created it yet. Okay, so far so good. This, as I said, you're going to see a second time very similar, almost identical, except it's going to be called PM cycle. And really the only difference is that these are going to be decreases rather than increases. So by increasing green and blue, it got brighter. By decreasing it, it gets darker. Okay, so let's go ahead and paste that in. So this is its own coroutine, so it's separate. So make sure it is not inside the other coroutine. As you can see, the little red squiggly went away now that we defined the new routine. And again, it's very similar. IEnumerator PM cycle. Again, we said we wanted the green and blue to increase during the AM and decrease during the PM. Same thing, it's going to be done in an increment of 1 second. You can use any amount divisible, quarter of a second, tenth of a second, whatever you want. And again, we're going to have this happen 15 times. So if I is less than 15, add 1 to it. skyrgb.g, this time we're subtracting, so minus equals 0.05f, so we're using the same amount. Minus equals 0.07f for the blue. And again, change the background color component of background color aspect of the camera component. I want to make sure I'm using the proper terminology. The camera is a component. So if I is less than 15, we have not done this 15 times yet, then go ahead and start coroutine PM cycle. So it comes back up here. Else, if we've done this 15 times, we need to again set I back to 0 and then start night cycle. So now night cycle is going to look slightly different, and in fact, it's simpler. So let's go ahead and paste that in. So just like the other two coroutines, it's its own coroutine. Now, we don't actually want the night to change color during the entire 30 seconds, okay? So what we're doing is we're just waiting 30 seconds, not making any color changes, then go back to AM cycle. So what have we done? We've completed a complete loop. So when this camera loads, it starts the AM cycle. The AM cycle runs until this has happened 15 times, and then it starts the PM cycle. PM cycle does the same thing until it runs 15 times, goes to the night cycle. Night cycle waits 30 seconds and then goes to AM cycle. You now have a closed loop. It will keep repeating itself over and over again. You have now created a corresponding synchronized sky change for, to match that light, the directional light. Now, like I said, it's not going to look really great because it's only 15 changes and it's fairly substantial. So as you make this number smaller, you also have to make this number smaller because you're making more changes. Therefore, the change has to be a small amount and it'll look much better. But again, if I was to do this in such a way that it would look really good, this would be like a 30-minute video, and who wants to see that? Okay. So that's just about it. Let's actually run this now and make sure I did not miss anything. Oh, and one last thing, since everything is meant to be synchronized, we started last time with this facing down, but since we said we want it to be starting at the crack of dawn, what we're going to do is you're going to rotate that so it's facing, the direction of the light is right at the horizon. So that means we need to set this to 0. As you can see, the shadows are moving. The ground is getting brighter because of the light. The sky is getting more blue, brighter because of the separate color coroutines. And right about there is peak. And now it's starting to get darker again. So like I said, if you want to nitpick, it really shouldn't start getting darker until like late afternoon. But even at this, I'm kind of rambling and probably not explaining this as clear as I should. But as you can see, it works. Now it's going to have the 30 seconds of night. And then it will rotate again, and we'll just wait for the sky to get overhead so you can see that again it is peak blue when the directional light is pointing straight down when it's overhead. And again, you won't have this glow in your version as long as you're using an actual terrain or using blocks. It's because the ground under it is a plane, and planes are one-sided, so the light is coming through it. And there we go. The shadow is about centered, peak blue, and now it gets darker. All right, there you go. So that is now a more complex day-night cycle. I hope I explained this well. I wanted the video to be short, but I wanted it to be clean. And so that's about it. So the main thing that you're going to do, you're going to reduce this and reduce this. That way it's much more subtle changes. And you would also have to change this because 1 second, excuse me, well, yeah, 1 second times 15 would be 15 seconds. So if you're reducing this, then this has to come out to exactly, so is that these comes out to 15. So 1 times 15 for 15 seconds. If this is 0.5, then this would have to be 30. 30 times 0.5 is 15, so on and so forth. So this and this multiplied has to come out to the amount of time that you want the AM cycle to be. And then, to be honest, I just copied this, pasted it for the PM cycle, and then just made a couple changes. So that way you don't really miss anything. Because again, the only difference between these two is the name and that you're subtracting rather than adding. That's it. So I hope that this was helpful. I hope that you found this useful. And if you want, I will do one more. I talked about maybe doing a moon. I couldn't get the lighting quite right. It technically worked, but it didn't give that nice kind of blue glow that I was trying for. So I might take one more shot at it. But at least now you can see a couple options as far as if you use the skybox, it will automatically calculate based on the position of the directional light. If you don't want to use a skybox, you can now change the sky manually on your own. Maybe you could do one other thing where in the night sky, once you hit a certain time, you could maybe have a particle system overhead that are the stars. That's one thing that you could do. It'd just be a little bit complicated as far as how to make those stars not be seen during the night and have them kind of fade in as it's getting darker. But again, that's the whole point of having a more advanced tutorial, is that you start dealing with those dicier issues. So I think this was a good, solid medium challenge. That's why we didn't jump into it in the first video. Like I said, IEnumerator itself really requires an explanation. So that should about do it. Again, I hope you found this useful, and I hope you have a good day. If you liked the video, please do a like. That way I know that people are actually watching it, because I don't find the analytics very good. And please leave a comment if there's something you specifically want to see, like can you add the moon, or can you add whatever, can you add something, since we're doing manual color changes, maybe you want to see a certain color on the horizon, that kind of thing. So anyways, if you want to do that, then leave a comment, and please enjoy the rest of your day.